All right, so we're going to do 6 through 10. So here we have one. Let's separate the atoms. So we have F, E, O, and C. Then we have F, E, O, and C. I always like to put them in the same order so that you can look straight across. So on this side, there's a 2. So Fe is 2. Now we got to be careful with the oxygen. See, oxygen has a 3 here, so I'm going to put a 3 above here because we have an oxygen right here. So that's 1. So this plus sign means we got to add 3 plus 1, which gives me 4. And then carbon doesn't have a subscript, so it's 1. So Fe is 1. And oxygen has a 2, so that's 2, and then carbon has a 1. Now, if you notice right here, you see an L, you see a G, an S. Remember in my video that explained about when we first started talking about balancing equations, I pointed out that sometimes you may see these after your element or compound in the equation. It's just telling you the state of matter. So an S stands for solid, G stands for gas, L stands for liquid. And then there's a fourth one called AQ, which is aqueous, and that means it has been dissolved in water. So you can go back and look at the PowerPoint balancing equations. You'll see those because you do need to know those symbols, but they have nothing to do with balancing the equation. It's just telling you the state of matter. All right, so we've got Fe is 2, Fe is 1, so I'm going to put a 2 here because 2 times 1 Fe gives me 2. So now our Fe's are good. And now we're looking at our oxygens, and we see that over here we have 4, over here we have 2. So if I put a 2 here, that gives me 2 times 2 oxygen is 4, and then 2 times 1 carbon is 2. Now I go back over here and I put a 2 here. That changes my carbon to a 2. But also it changes our oxygen. So 2 times 1 oxygen, that's now 2 on this side. So we got 2 plus that 3. So that becomes a problem. So the 2's aren't working. So the thing to do is to change your 2 and make it a 3. So you just go up 1. So you want to use the smallest coefficient as possible. So I'm going to try 3 there to see what happens. So I put a 3. So 3 times 1 carbon is now 3. 3 times 1 oxygen is now 3. So 3 plus the 3 gives me 6 oxygens. Yeah, so there's 3 still for the carbon. All right, and then over here, let me change this 2 to a 3. So I'll put a 3 here, which that's now 3 carbons. So we have 3 carbons, 3 carbons, 3 carbons there. And then it changes my oxygen to a 6. So now we have 2 and 2, 6 and 6, 3 and 3. So to clean up this answer, let me do this for you. So there should be a 3, there should be a 2 and a 3, and that's a 1. You can leave it as that, but that's your answer for number 6. All right, for number 7, so let's look at that. Now I'm going to show you a little trick. So we have hydrogen, which there's a 2 after the hydrogen, so that means that's 2 here. But we also have hydrogen right here. So whenever it's in parentheses, there's 1 hydrogen inside the parentheses, but you got to multiply it by the 4. So there's actually 4 hydrogens there. So that's 2 plus 4, that is 6 hydrogens. So there's 2 here and 4 here. So that gives us 6. Now I want to concentrate on the SO4. Remember SO4 back in when we were doing our formulas? That's a polyatomic. Even though that's made up of sulfur and oxygen, I'm going to leave it as SO4. And there, since it's not in parentheses, it's only 1. Now this Pb, that's lead. There's no subscript, so that's 1. And then oxygen, because it's inside the parentheses, that's 1, but you have to times it by the 4. So that gives you 4. Now let's put it in the same order. We have H and then SO4, then we have Pb, and then we have O. So now let's check our answers here, or count our atoms. So hydrogen is right here. So that means it's 2 because it has a subscript 2 after it. SO4, you see here's my SO4 is in parentheses with that 2. So there's 2 SO4s. Pb, there's no subscript, so that's 1. Oxygen, no subscript, so that's 1. So right off, we see that hydrogen is 6 over here and 2 over here. So we're going to not do the hydrogens quite yet. Let's go ahead and solve for the SO4. And so over here, we have 2 SO4s and only 1. In order to make the 2 SO4s here, I'm going to put a 2 in front of that. So now that 2 times S, 2 times O, so that gives me 2 SO4s. Really, that's 2 sulfurs and 8 oxygens, but we're keeping the SO4 together. All right, now that changes my hydrogen, 2 times 2, now that's 4. Let me erase that so we won't have so many numbers. So it's no longer 2 right here for the hydrogen. We now have 4 here. Plus there's 4 here. So now we have a total of 8. All right, so now, again, our hydrogens are still not balanced. Let's see what else is not balanced. So lead is good, our oxygens. So let's go ahead and do our oxygens. So there's 4 here, and there is only 1 here. So let's make a 4 because, oops, so 4 times 1 gives us 4. But now we have 8 oxygens. So as you can see, 4 times 2 is 8. Now that made it all balanced. So you should have a 2, nothing in that one. You could put a 1. You could put a 1 here, and then your 4. So 2, 1, 1, 4. Okay, let's go to number 8. So let's count our atoms. Aluminum, hydrogen, chlorine, aluminum, hydrogen, chlorine. So aluminum is 1, hydrogen 1. Over here we have 1 aluminum. There's a 2 after the hydrogen. There's a 3 after the chlorine. So right off we see the 2 aluminums are good, but our hydrogens aren't. So, yep, we're going to put a 2. So 2 times 1 gives us 2. And then 2 times 1 chlorine gives us 2. But that still doesn't work for the chlorines. So you just have to keep moving to the next number. I can try 3 to see if that would work. I could try 4. I could try 5. And then I can try 6. And 6 is actually your answer. You just have to go one by one. So I'm going to put a 6 here so you can see. Well, Oh, I had my eraser. So I put a 6 here. So 6 times 1 hydrogen is now 6. 6 times 1 chlorine is now 6. Over here, I can make this hydrogen 6 by putting a 3. So that hydrogen is now 6. And then this chlorine, I can make it 6 by putting a 2, because 2 times 3, see that 2 and that 3 gives us 6. And then that also changes my aluminum to a 2. And then now I have 2, 6, 6, but I have 1, 6, 6, so I'm going to put a 2 here. So to make it shorter, I knew it's going to be a 6 here, but you could have tried a 3 to see how that worked, a 4, and then a 5, and then you would have seen that the 6 was the answer. All right, let's go to number 9. Let's see, there we go. All right, so number 9, we have some more polyatomics. See, we have PO4 over there, PO4, SO4. They have to be on both sides in order for you to do that. So let me show you how to set this one up. So we got Ca, PO4, H, and SO4. This kind of speeds it up so you don't have to separate all of those. I'm going to do the same thing over here. Ca, PO4, H, and SO4. So Ca has a subscript 3 right there. So we're going to write a 3. This PO4 is in parentheses with that 2. So that means there's 2 PO4s. Hydrogen has a 2 after it. So that's 2. SO4 is not in parentheses. So that means it's 1. Calcium has no subscript. So that's 1. This PO4 has a 2. So that means there are 2 of them. H right here is 2 inside the parentheses. You got to multiply by the 2 outside the parentheses. So that gives me 4. And then here we have SO4. It's not in parentheses. So that means it's 1. So right off we see calcium has, there's 3 calciums. And over here there's 1. So we're going to get it to equal. Oh, I'm sorry. There's a calcium here and a calcium here. So actually, let me erase that number. I just caught myself here. So here you have a calcium and here you have a calcium. So there's actually 2 calciums. So I'm going to come back to those. So let's look at the hydrogens. There's 2 here and there's 4 here. So we can make this hydrogen right here a 4 by putting a 2 in front of it. So now we have 2 times 2 is 4. But it also makes this SO4 right here, this 2 makes it there are 2 SO4s. So I'm going to change that to a 2. Now I'm going to come back over here, and this SO4 needs to be 2. So in order to do that, I put a 2 in front of that. So now this SO4 right here is 2. But it also changes our calcium. So 2 times 1 calcium, there's 2 here, plus, remember the 1 that's right here. So 2 plus 1. So we're going to add 2 plus 1, and that now is 3 calciums. So we have 3 calciums, 3, 2 and 2, 4 and 4, 2 and 2. So there you have it. So our answer, you only needed a 2 here and a 2 here. So you could have put a 1 if you wanted to right there. All right. And let's do the last one, number 10. All right. So for number 10, notice we do have a PO4 on this side, but there's no PO4 on this side, so we have to separate all of them. So we got hydrogen, phosphorus, oxygen, and chlorine. All right, and then we're going to put the same hydrogen, phosphorus, oxygen, and chlorine. All right, so got to be careful with our hydrogen. There's a hydrogen here, that's 3. So I'm going to put a little 3 here. And then there's a hydrogen here, which is 1. So 3 plus 1 gives me 4 hydrogens. Phosphorus, no subscript, 1. There's a 4 after the oxygen. And then there's no subscript after the chlorine. That means 1. All right, over here, there's a 2 after the hydrogen. There's no subscript after phosphorus, so that's 1. Oxygen, no subscript, so that's 1. And then there's a 5 after the chlorine, so that's 5. So right away, hydrogens are unbalanced, but we're not going to try to balance those first because you have hydrogen in 2 different places here. So we're going to do something simpler. We're going to jump over to the chlorine. In the video I had posted, it always says try to do the hydrogen and the oxygens last. So chlorine 1, this chlorine is 5. So to make this one 5, I'm going to put a 5 there, which makes that one 5. But it also changes this hydrogen to a 5. So now instead of 1, there's 5 here. So now 5 plus 3 gives us 8 hydrogens. All right, so then I'm going to go over here and make my hydrogens equal 8. So what number times 2 gives me 8? And that would be 4. So 4 times 2 gives me 8. But it also changes my oxygen to a 4. And voila, it already made your oxygens to equal. So this is just a trial and error kind of work. You just have to know the rules, making sure you multiply that coefficient by everything behind it, and you add when you need to. Like for the hydrogens here, you got 3 here, plus you had 5 here, so that makes 8. So I hope this was helpful.